Hello students, this is Dr. Meena Patange and today we are going to talk about vitamin D. In the previous session you have learnt all about vitamin A and in this session you will be learning all about vitamin D, its history, chemistry of vitamin D. Now vitamin D is also known as sunshine vitamin. Now because of several reasons we will go about it in detail. Nowadays, in fact, recently it is considered more of a pro-hormone than a vitamin because it also plays a very important role as hormones in the synthesis of many biochemical products which are essential for the metabolic pathways in the body. So, therefore, it is also called as more of a pro-hormone than a vitamin. But this vitamin D can be, it is also called as a sunshine vitamin because when the ultraviolet rays of the sunlight strike our skin, the precursor for the active form of vitamin D, that is 7-dehydrocholesterol, which is found in the skin, it gets activated and then this is how there is a biosynthesis in the body of vitamin D. So, mostly the required amount of vitamin D in our body can be obtained by our exposure, our entire exposure to outside direct sunlight even for 5 to 15 minutes in a day. Now, this vitamin D, as I said, it is called as a sunshine vitamin, but it is found in foods in small quantities. Therefore, it is added to food or fortified to food and also most often it is consumed as a supplement. So, these are the three ways in which vitamin D is available to our body for its various functions. Vitamin D activity in the body is shown by a group of chemical compounds which are called as sterols, which are wax like substances. These are quite stable to heat as well as that is high temperatures, then they are also very stable to acids, alkalis and oxidation. So, let us study the history of vitamin D, which is very interesting. Now, there was a scientist called as Sir Mellanby, who was an English scientist and who was very much concerned with the prevalence, high rate of prevalence of rickets. So, now we know that rickets is caused due to deficiency of vitamin D. So, he was very much concerned with the prevalence of rickets in Scottish people and English people. In fact, this rickets was also called as English disease. So, what he did, he was a follower, a big follower of Sir Maccallum. Now, Dr. Maccallum, you know very well, was the one who identified the role of vitamin A in the body as well as the diet, and he was the one who discovered that vitamin A deficiency can lead to so many symptoms. So, Sir Mellanby, he was very much interested in the work of Dr. Maccallum. So, what he did, he took the diet of Scottish people, that is a very stable diet. And what is that staple diet? It was chiefly made up of every day consuming oatmeal. So, you know that very well, oatmeal will not have or is not a very good source of any fat soluble vitamin. So, he took this oatmeal and he took a number of experimental dogs and he started feeding them over a period of time every day with only oatmeal. And what he also did is he put them inside, that is, he didn't allow them to get exposed to sunlight. Now, very obviously there is no vitamin D in the diet and there is no vitamin D getting activated from sunlight. Therefore, very obviously these dogs develop rickets. So, since he was a follower of Sir Maccallum, so what he did is he took cod liver oil, and we know that cod liver oil nowadays definitely is a very good source of all fat soluble vitamins. So, that time cod liver oil was associated only with being a good source of vitamin A. So, he took cod liver oil and he fed these dogs the same oatmeal along with cod liver oil. So obviously, since there was a supply of regular supply of vitamin D through cod liver oil in the diet, these dogs were able to overcome rickets. So he said that yes, he didn't know there is a new vitamin called vitamin D which is responsible for rickets, but since he knew that cod liver oil was responsible for having vitamin A, so he related vitamin A and rickets together. But meanwhile, Sir McCollum, who moved from University of Wisconsin to Johns Hopkins University, was following the work of Sir Mellanby. So what he did, he wanted to test this hypothesis of vitamin A and rickets. So he took cod liver oil, which is a rich source of both vitamin A and D, and he bubbled oxygen or it underwent oxidation. Now because of this oxidation, vitamin A was destroyed, and then the remaining cod liver oil, which is rich in vitamin D, was again used for experimenting to overcome the deficiency symptoms of vitamin D, that is rickets. So he definitely identified that this cod liver oil, which did not have any vitamin A, was not able to cure the symptoms of deficiency of vitamin A, but it was able to cure the deficiency symptoms of vitamin D, that is rickets. So later on, and they did some more work on this, and they identified this essential nutrient as vitamin D, which is responsible, he and his colleagues. So they discovered or identified or came to a conclusion that vitamin D is an essential nutrient, which is also can be called as essential vitamin, which is responsible for preventing deficiency in the form of rickets. Now let us understand the chemistry of vitamin D. Now vitamin D is found in nature in two inactive forms, that is in the animal origin vitamin it is called vitamin D3 and it is also known as cholecalciferol, and the precursor for this cholecalciferol is the 7-dehydrocholesterol. Now in plant sources, that is vitamin D2 is found in the form of ergocalciferol, and the precursor for this D2 or ergocalciferol is ergosterol. The vitamin D, which is obtained from sunlight, dietary sources and in the form of supplements, is the inactive form of the vitamin D. Now this, in order to become active and be available to the body for various functions, needs to be converted into its active form, and this active form is obtained only after the inactive vitamin D undergoes two hydroxylations in the body. The first hydroxylation occurs in the liver, wherein the inactive vitamin D is converted to 25-hydroxy vitamin D. Now the second hydroxylation takes place in a very essential part of the body, that is kidney. Now in kidney, the 25-hydroxy vitamin D is then converted or hydroxylated once again, and it is converted to a form called as 1,2,5-dihydroxy vitamin D, which is the active circulating form of vitamin D made available to the body. So after the first hydroxylation in the liver, the form of vitamin D, which is 25-hydroxy vitamin D, is also known by another name called as calcidiol. Now after it undergoes the second hydroxylation in the kidney and becomes 1,2,5-dihydroxy vitamin D, this form is also called as calcitriol. In continuing with the what we call the chemistry and metabolism of vitamin D that we have seen, and the two forms of vitamin D which get hydroxylated, first in the liver and then in the kidneys. Now in the kidneys, as I told you, this 25-dihydroxy vitamin D gets converted to 1-alpha-dihydroxy vitamin D, which is the active form of vitamin D as a hormone circulating in the or available in the body. Now this 1 alpha dihydroxy vitamin D needs to be controlled by or certain factors which affect this production or the levels of 1 alpha dihydroxy vitamin D. What are they? One, the plasma or the serum levels of phosphorus, calcium, parathyroid hormone that is produced by kidneys, then the growth factor 23 or what we call fibroblastic growth factor 23 and the levels of 1 alpha dihydroxy vitamin D itself. While kidney is the main site of the second hydroxylation of 25 hydroxy vitamin D to 1 alpha dihydroxy vitamin D, there have been several sites other than kidneys, that is extra-renal sites as we call them technically, are found to be also the places where this conversion is taking place in the body. Now what are these sites? It takes place in the skin, in the breast tissue, in the colon, in the prostate, as well as in the immune cells and tissues, or what we call it is very much responsible for the active form of vitamin D even in the immune cells. So these are the extra-renal sites where the second hydroxylation can take place other than in the kidneys. The most metabolically active form of vitamin D which is available to the body for the various functions is nothing but 1 alpha 25 dihydroxy vitamin D.